Okay, so completing the square. So this would be to solve a quadratic. Okay, now I've got a quadratic here that I know I could factorise, but I'm using this so that you can see that we can get two good answers. Okay, now in the exam, particularly on AQA, they very, very rarely use the words completing the square or the term completing the square. Usually what they'll say is they'll say put this equation in the form of x plus a all squared plus b. Okay, and it usually comes as a two-part question. Usually they'll say put this equation in this form, which is completing the square, and then the second part of the question will be to solve it. Okay, so when we do this, this is completing the square, and you'll see when I do it how fairly simple it is. Now when we complete the square, what we do is we have an open bracket and we take one of the x's. This is always done the same way. We take the sign and we take half of this coefficient value. So half of 6 would be 3. Okay, no x, just that. And we would square that, hence the term completing the square. Now I'll explain to you what happens. X plus 3 all squared would be x plus 3 multiplied by itself, x plus 3. Now if we multiply this out, x multiplied by x will give me x squared, x multiplied by 3 will give me 3x, 3 times x will give me 3x, and 3 times 3 will give me 9. Now if I simplify this, I get x squared plus 3x is 6x plus the 9. Now you'll see that the x plus 6x, x squared plus 6x, happens. It will always happen. Okay, if this is a minus, you just put the minus in, but it will still give you the first two terms of the equation. The only thing that's different is this, the number. Now here we have 9, but when I expand this, I know I'll get 9, but I want 8. So what do I need to do to 9 to get 8? Well, I need to subtract 1. Okay, so if I complete the square and I know that it gives me this here, then I know I need to subtract 1, and that will give me this equation back. So I can say that this equals 0. And as you can see, I've now put it in that form. So I can now say that A equals 3 and B equals -1. Okay, so even if you think when I solve this, you think, oh, this is too much, you can see that putting it into this form is not difficult, okay, and this will give you 1 or 2 marks just by virtue of the fact that you've done this. Now, if we're going to solve this, we want to find out what x equals. Okay, so the first thing I need to do is move this random 1 across. So I'll have x plus 3 all squared equals, now if minus 1 comes over here, it becomes plus 1. So I had a minor fit there because I'm old. So we get plus 1. Now I need to get this x out of the bracket and it's being squared. So what I do is I apply the reverse to squaring something. Now the reverse of squaring something is to find the root of it. So I root both sides. Okay. So for example, if I've got 4 squared, okay, now I know that that gives me 16. Now if I find the root of 4 squared, okay, now underneath here I'll just write this here. Now 4 squared is 16, so these are both the same thing. Now the root of 16 is plus or minus, but we'll assume it's plus for the moment, is 4. So the root of 4 squared must also be 4. So you can see that if something is being squared and you find the root, you get what's inside. Okay? You don't get 4 squared out, you get 4 out. So if I root this, I get x plus 3. Okay? In the same way as I would get 4. But I need to root both sides, so I need to find the root of 1. Now what I need to do is move this number over because I want to know what x equals. So x equals the root of 1 minus 3, because remember the plus becomes a minus. Now at this point we will get two values because the root of 1 is 1. Okay, because 1 times 1 gives us 1. But remember, the root of any number is positive and negative. So first I say, okay, well I'll take the positive value of this root. So x equals 1, or if you want plus 1, minus 3. So x must equal, now 1 minus 3 gives me minus 2. So this is one of my solutions. Now if I take the root of 1 as being minus 1, I would have minus 1 minus 3. So x would equal minus 1 minus 3 would be minus 4. Okay, because it's a quadratic, I usually expect there to be what we call 2 real roots. Sometimes you'll get 1 real root. It is possible to get no real roots, but at GCSE this doesn't happen. Okay, so this is how we solve it, and it's done every time you complete the square. It's done in exactly the same way. So to learn this just means to keep doing it over and over again, and you'll find that it gets boring after a while. Okay. So what I'll do is I'll pause the video now and I'll put up another one and I'll go through it with you. Okay. So we've got a new equation here. So x squared minus 6x minus 16 equals 0. So we put it in this form. So we take one of the x's, the sine, and half of the coefficient value, and we square it. Okay, now I know when I square this that this x squared and this minus 6x is going to happen. The only thing that's going to change is this number. Now because I know that, all I need to do is square minus 3. So minus 3 multiplied by minus 3 gives me plus 9. So if I have £9 in the bank, how much do I need to draw out to get minus 16? Okay, so I would need to draw out £25. Okay, or to put it another way, if I had 9, what would I need to do to 9 to get minus 16? Well, I would have to subtract 25. Okay, and this will equal 0. So in the first part of the question you can say that A is minus 3 and B is minus 25. So now all I do is I solve it in exactly the same way as I did before. First thing I do, move the number. So x minus 3 all squared equals 25. Okay, remember the sign changes. Now I root both sides. So if I root x minus 3 all squared, I get x minus 3, and this will equal the root of 25. Now I move the minus 3 over, so x equals the root of 25 plus 3. Okay, now if it helps you, you can write plus or minus in front of this root to remind you that there are two values. Okay, so let's say we go with the plus value, so we have x equals, now the root of 25 is 5, so we're going with the plus value, so this would be 5 plus 3, so we can say that x equals 8, so that will be 1 answer. Now we take the other value and we say the root, the minus root of 25, so the root of 25 is 5, but it's minus 5 plus 3, so x will equal minus 2. Okay, that's pretty much it. Now what I'm going to do is I'm going to do one that won't necessarily give you, we've got two integers here, so let's do one that has no integers. So let's say we have x squared plus 4x plus 1, and this equals 0. Okay, I do exactly the same. A bracket, one of the x's, half of this value. Okay, you don't take the x, just half of the coefficient, and we square it. Now I know that the x squared and the 4x will happen. The only thing that won't happen is the 1. So if I square 2, I get 4. Now what do I need to do to 4 to get 1? I need to subtract 3. So this will equal 0. So I can answer this first part of the question. Now to solve this question, first thing I do again is move the number. So I have x plus 2 all squared equals 3. Now I root both sides, so I get x plus 2 equals the root of 3, and then I move my number over, so I get x equals root 3 minus 2. Now, on a non-calculator paper, you wouldn't be expected to know that the root of 3 is 1.732, okay? So they would just say leave this in third form, so you would leave it in this form. But if you had a calculator, then, and it's a calculator paper, then you would be expected to give an answer, and they would tell you to what value. Okay, so remember it's plus or minus the root 3. Okay, so let's say we have a calculator paper and they want a definitive answer. So this would be, now I happen to know that the root of 3 is 1.732, so we would have 1.732 minus 2. Okay, so x would equal, and I'll just get my calculator, so we have 1.732 minus 2 gives us an answer of minus 0.268. Okay, so that's one solution. Now the other solution is it's the minus root, so we would have x equals minus 1.732 minus 2. So obviously x would equal minus 3.732, and that will be your second solution. So on a calculator paper, which is usually where you will get this, you will get a root that you won't know and you'll have to use your calculator. So this is what we've done here. Okay, and remember that the x values are where the parabola, when you graph it, crosses the x-axis. So on this particular equation, the graph would cross, or the parabola, the curve would cross the x-axis at 8 and minus 2. Now here, the curve would cross the x-axis at minus 0.268 and minus 3.732. Okay, now you can, if you want to, draw this out and prove it to yourself, but you can take my word for it if you want to. Okay, so I hope this helps. It is just practice. You may have noticed that these values that I need to halve have always been even numbers. Okay, it's not really until A level that you get to odd numbers, but it can still, it's still done, but what you're doing is squaring fractions, and they don't really want you to get into that area. Okay, but this is a good way of solving an equation without using the quadratic formula. So I hope this helps, and just keep practicing.